Quality control tools and techniques are essential in monitoring and maintaining the desired standards for the project deliverables. These tools enable the project managers and quality teams to identify the potential issues early, also understanding their root cause and implement corrective measures effectively. They ensure that the project outputs aligns with the project expectations in terms of quality that were predefined with the quality criteria. The key tools and techniques here we have also covered in the first session. The key inputs we all know: the project management plan, the project documents, and the project management plan here. When remember when we talked and we implemented the quality management plan, where we have gathered all of these quality requirements from the stakeholders and we have documented these. So now it's the time to go back and ensure that the current project is implementing whatever we planned and we were requested to follow as part of the quality management plan. Approved change request can also be one of these. If you find any while the execution and you find one of these, let's say, defects, so you have to apply change request to fix these defects in case if it impacts the project constraints. One of these inputs, which here we are talking about, which is the deliverables. So these deliverables, it's the result of the uh, teamwork where they have, let's say, identified. Already have identified as part of the planning phase. The team has worked to execute it and to implement these deliverables. So now it's the time to inspect these deliverables. We also cover the work performance data and these tools and techniques, including the data gathering. We all know what does that mean: data analysis, the inspection, testing, or the product evaluations, data presentation or representations, and the outputs. Here we have the quality control measurement to measure, let's say, the baseline of the quality, say the number of defects, the number of errors, say the number of issues compared to the baseline, also the verified deliverables. So after you complete quality control process, you need to have a list of the verified deliverables that it meets the stakeholder expectation in terms of quality and it's ready to be delivered to the stakeholders. The work performance information, as we talked about, which is useful to understand, which combines the work performance data, compare it with the baseline, and then it give you the work performance information. Change request already we have talking about. Project management plan updates if necessary, and project document update as well. To start with the, let's say, one of these important tools here we have is the statistical process control. The statistical process control, which is known as the SPC, it uses the statistical methods to monitor and control the production process. By using these control charts, it helps to distinguish between the common cause and special cause variation. And this method, it aims to maintain the process stability and predictability. For example, here let's take in a manufacturing project, the control charts, it helps tracking the variations in product dimensions. Also, it helps by distinguishing the routine variations from the anomalies. And this ensures the product remains with an acceptable quality limits while optimizing the process efficiency. We also has cause and effect diagrams, which known also as the fishbone diagrams. The fishbone diagrams, it helps to it help you as a project manager or whoever who's using this tool, or we also call it the Ishikawa. So it's Ishikawa or fishbone diagrams. It's cause and effect diagrams. Helps to help you identifying the root causes of the quality issues, and it helps you also in categorizing the potential causes into groups for better analysis. Cause and effect diagram, or the Ishikawa or the fishbone diagram, is a systematic tool for identifying the root causes of the quality problems. For instance, let's take here a software development project which is experiencing some delays. Now, the fishbone diagram or the cause and effect diagram or Ishikawa diagram can reveal the issues like the heavy testing or endless testing, or let's say some of these root causes like the unclear requirements or insufficient resources. So, using these fishbone diagrams, you keep asking yourself why this issue happens 5 times, 6 times, 7 times until you reach into the root cause of the issue. And this will help you to understand what is the reason behind of that issue. As we mentioned, the inadequate testing or the unclear requirements or insufficient resources for the testing, for example. So this, let's say, fishbone diagram or cause and effect diagram, it helps clarify and aids the targeting a specific areas for improvement to avoid being falling into the same issues in the later processes or at the later stages of the project. Sampling techniques, we already have talked also as part of the inspection doing statistical sampling. So sampling technique provide a cost-effective way to ensure the quality without inspecting every unit. It reduces the need for inspecting all items by examining a sample of that unit, for example. Case if that you're delivering, for example, 100,000, let's say, unit of microcontrollers or microprocessors, to save the time, let's say, by needing to inspect all of these 100,000 units, you can choose, let's say, a sample or a statistical samples of these 100,000 units. So you can conduct your, let's say, inspection on these. And the common types here, including the random sampling and stratified sampling. This technique of sampling, it ensures the efficiency while maintaining reliable quality checks. Now let's talk in more in depth about the Pareto analysis and quality control. Pareto analysis is a rule where it's based on 80-20 rule. And that rule, it says that 80% of the issues stem from the 20% of causes. And let's say this tool or this methodology, it helps by prioritizing the efforts on high impact problems. Also, you can visualize using this Pareto charts to help you identifying these affecting quality problems. So again, it identifies the most significant factors affecting the quality. So based on the 80-20 rule here, again, the 80-20 rule here, it means that 80% or 80, 80 times of the issues stems from the 20% of the causes. So think of these top 20 causes of a problem. So 80% of these issues come from these 20% of these causes. And let's say here, let's take an example here in a service industry project. Analyzing the customer complaints might reveal that most complaints stem from, let's say, a few recurring issues, like delays in response time, and addressing these areas can significantly improves the overall quality. It's like analyzing the most repetitive issues that might impact the, let's say, the project or the industry or the, let's say, the service level of your project. So by analyzing these top causes or repetitive causes, you can, let's say, solve these problems to help you addressing these areas to improve the overall quality. The control charts and quality monitoring. So control charts track the data points against upper and lower control limits to identify the trends or outliners. Control charts here, think of it's like a visual tool for monitoring the process variability over the time. It includes control limits to identify out of control process. So think of, let's say, you have the upper limit or the upper limit of having, let's say, defects in your software or one functionality. Say that you have set the minimum limit is to one, the maximum limit here is to four. So, in case that during the continuous testing, you keep scoring, let's say, one or three or two, so within one and four, that will be called, let's say, let's say the control chart, where you control within the min and maximum, or the upper limit and maximum limit as a data point to, and we call it as a control limit to identify the trends or outliners. In case that you have faced, let's say, um, a repetitive testing that it seem or shows that you have five or six, let's say, number of defects, since your average is from one to four, and you kept, let's say, facing five and six number of defects, so now you have to take an action to, let's say, to take a corrective action, ensure that these controls over, say, the functionality does not go over than the control limits that you have set is one to four. It includes the control limits to identify the out of control process, and it supports real time decision making. One of these, let's say, tools here we have also is the histograms for data distribution. Histograms, as we know, it provides an insight into the, let's say, data distribution. It helps you identifying the trends and anomalies within, let's say, your processes. Displays the data frequency distribution, and it identifies the patterns and trends quality metrics. It's useful for analyzing the effects and performance measures. Let's take here an example of an IT project. A histogram of, let's say, bug occurrences across, let's say, modules can reveal areas that requires focused quality improvement efforts. Also, these scatter diagrams as part of the tools and techniques that you can follow to understand the relationship analysis between, let's say, the two variables within the quality control process. So scatter diagrams explores the relationship between the variables. It plots again the relationship between two variables, and it could identify the correlation that could impact the quality outcomes. And by identifying the high, let's say, correlated factors within your quality issues, you can, let's say, focus on these high correlated, let's say, variables or issues that you have, let's say, to focus on to resolve these issues. It's mainly useful for the process improvement initiatives. Also, one of these tools we have here is the benchmarking in quality control. So, benchmarking involves comparing performance, let's say, with industry standards to identify any gaps and areas for improvement within your processes and within your projects. So, the benchmarking, as one of these key tools used in quality control, it compares the project metrics against these industry or internal standards. Think of these industry standards in terms of number of software defects or number of construction, let's say, safety incidents. So these can be considered as, let's say, an industry standards. So the benchmarking, it helps you by identifying the performance gaps and improvement areas. Also, it drives you as a project manager to have a quality or continuous quality improvement within your project. By looking into the best practices, by looking into the best results, you can learn from these best results and apply into your project. And also ensure that your metrics, let's say, improve as part of your continuous improvement. For example, here let's take a logistic project or a logistics project. Benchmarking activity or a benchmarking activity within your project Benchmarking the delivery time against the competitors highlights the areas that needs an optimization and ensuring the competitive service quality. So think that you are running a project where you're trying to deliver food and services to one of these clients. As the best practice here to ensure that you are meeting the quality requirements, think of the other competitors who already have been market and delivering the same services and let's say meals or foods, whatever service that you are delivering. So think of their processes and how long does it take, for example, to deliver an item, how long does it take, let's say, to sanitize the item, how long does it take to ensure that the customer satisfaction is achieved. So with that being said, you can compare the best competitors, let's say, performance compared to yours, so you can find these areas of improvement that you need to work on to ensure that you are competing with these big competitors. Finally, we've talked a lot about all of these quality control tools and techniques. Quality control tools are integral part of any project success. From identifying the defects, using control charts, to prioritizing the issues with Pareto analysis. So all of these techniques provides an actionable insights. So ensure that you utilize these when doing your quality control as part of your project management, let's say, journey and quality control or quality management journey. All of these tools enable a proactive issue identification and endless resolution, ensuring that you have a critical role in the project success.